Hello participants, now we are starting lecture 38. Lecture 38 is micro sprinkler irrigation system. In previous lectures, we discussed about the water movement through porous media when we apply water through a drip emitter. We also discussed how to develop a dripper by using basic fundamentals of Navier-Stokes theorem and then solving this equation by using SolidWorks software and giving the appropriate design parameters and fabrication of a dripper. This particular topic which I am going to discuss here on micro sprinkler irrigation system, this topic also falls under the family of micro irrigation. Now, here we will discuss what is the importance of micro sprinkler system, how this can be installed, how important this particular system is, and what are the different system components, how this could be laid out in the field. We will also discuss about some of the points which are dealt in the design of micro irrigation system. So, as it says that the micro sprinklers are of low capacity water emitting devices, and they fall under the category of sprinkler type, but similar in size than conventional irrigation system. Conventional sprinkler irrigation system, and the discharge rate is relatively lesser. It is about 250 liter per hour up to this discharge. This delivers the water. These micro sprinklers are placed on relatively close rectangular or triangular spacing depending on the requirement, and they are given appropriate overlap. These could be used to irrigate close growing crops, potatoes, carrots, leafy vegetables, groundnut. This has been found that these crops response is much better. This method is reliable, highly efficient and easy to operate and handle. The system is seasonal, means one can use it and then bring it back after the crop season is over. It operates at the low pressure. It has a solid set installation, means once it is installed, then at the end of the crop season, the system can be removed or brought back, and then again it can be reinstalled when the new crop is being planted. The micro sprinklers differ from each other with respect to its size, shape, its performance, and according to the operating principle, micro sprinkler can be broadly classified as a rotating type or static type. So, in case of rotating, a halo rotor is provided just above the nozzle, and in which the water comes out under pressure. Unlike overhead sprinklers, micro sprinkler does not have any striking arm to rotate. This is what you see here. The on the top in the water is coming with the help, means here there is a micro tube, water comes with the pressure, and then it is giving the enough, means there is a enough pressure that causes the rotation, and then it is the water is coming out of the sprinklers, and that sprinkles around that. The curvature of the rotor is so designed that it is pushed by pressure of water flowing through it, and it starts rotating in the opposite direction of the curvature. So, curvature here is provided in the rotor. Accordingly, this makes the guide the sprinkler to rotate. In case of static type micro sprinkler, there is no rotor. Instead, a flat or conical hard plate is just above the nozzle, so that water coming out through the nozzle strikes against it and spreads in all directions. This is the cap which we are seeing on the top, this particular plate. So, this is a hard plate, and then this is a serrated. So, at time the hard plate becomes serrated, so that the water can be ejected through these serration in all directions. This is what you see, how the water is coming out on the top. So, water is getting distributed all throughout. So, there is equal distribution of water in all or particular specified duration. Maybe at certain part it is kept open and certain it is closed. So, it will be maybe it is used for half the circle or 1/4 of the circle or full circle. Micro sprinkler assembly, essentially it consists of a head, micro tube. So, this part is head. If you see here, this is the head part, and then there is a micro tube which is known as a spaghetti. It is, and then which connects to lateral pipe. So, this end here which we are seeing here, there is one connecting nozzle, or it is a similar to the barb which looks like the in case of drip emitters. So, supporting stake, there is a supporting stake. So, that this is the stake which hold the micro sprinkler at a specified height from the ground. So, if the crop height is little large, then this stake the further it is extended, and then another rod or plastic rod is made, so that the height can be increased. The head of the micro sprinkler is basically a rigid frame and made up of plate. The water emitting nozzles are fixed in different ways to sprinkle water. It is the frame which guides the micro sprinkler to precipitate water in different pattern and directions. So, on the top or in the side, or depending on the way the serration it has been made, accordingly the water distribution it takes place. The internal diameter of water emitting nozzle is very small. It could be in the order of 1 to 2 millimeter, through which the water comes out under pressure. The size of the water particle depends upon the internal diameter of emitting nozzle and pressure behind it. The micro tube is a semi rigid tube which is made up of LLDPE, that is linear low density polyethylene. The internal diameter of the micro tube is 3 to 6 millimeter. It joins the inlet opening of micro sprinkler with the lateral line. A small connector nozzle is also provided at the end of microtube to connect it to the lateral pipe. So, one end is connected with the of the microtube is lateral pipe, other end is connected with the nozzle. The size of this connector depends upon the size of the microtube. So, this connector will be according to the size of the microtube. So, this is what you can see here. This is one type of thing, that it means this part it goes to the lateral. So, this is the threaded part. So, sometime it is needed that there are some types of the micro sprinklers, which is directly it can be attached. So, this part it goes to the micro sprinkler, which is fitted here, other part is also. So, instead of putting into the lateral, they are when the high means discharge micro sprinklers are there, where this arrangement is normally used. This is the another type of threaded. So, threaded part it is connected with the micro sprinkler, other part this is a barbed, which goes inside the this particular this is connected, this goes inside the lateral pipeline and barbed. So, this is the another kind of arrangement, that both the ends to microtube, one end is the microtube, at the end also it goes to the lateral pipeline. So, it will depend upon the type of micro sprinkler which we are using, and then this size. Orifice control micro sprinkler, the most common micro sprinkler are orifice control emitters, where the flow rate at any given pressure is governed primarily by the orifice diameter. So, it is the relationship, because orifice type when we are talking means Q is directly proportional to the area and then the square root of the operating pressure. So, Q equal to C D into root 2 A into A the area multiplied by the root 2 G H. So, H becomes your operating pressure. So, orifice control emitters are turbulent flow devices, where flow rate is regulated by dissipating energy by friction of water against the wall of the passages and between the fluid particles themselves. Turbulent flow emitters have shorter flow paths and larger diameter passages than laminar flow devices. So, the concept is same as was being used in case of the micro irrigation drip emitters we discussed. The basic fundamental which are used there, these are also used for orifice control type of micro sprinklers. The flow velocities are greater than the greater and potential for clogging is less than the laminar flow devices. And with orifice control emitters, orifice diameter at the base of emitter determine the flow rate. So, top of the emitter determine the pattern and diameter of spread. Mainly micro sprinkler we use when the crop is close spacing. Beside this, clogging is another thing. So, this is the important part, that when the quality of water is poor and then drippers as well as filters, it gets clogged repeatedly. In that case, because the orifice size in case of the micro sprinkler is relatively larger. So, the possibility of getting clogged problem, it is minimum in this case. Vortex flow micro sprinkler, this is the another kind of the micro sprinklers. So, vortex control emitters are less sensitive to pressure variation than laminar or turbulent flow emitters, and such emitters has the exponent 0.4. This exponent is this Q, that is discharge out of the vortex control micro sprinkler, is given by discharge Q equal to K d into P to the power x. P is the operating pressure, K d is the coefficient of discharge. So, x is the exponent. So, here vortex flow when we are talking. So, x is 0.4. In vortex emitter, water is forced to form a vortex or whirlpool at the center of the emitter. As water rotates, centrifugal force pushes it toward the outer edge of the thing. This is what you see here. The water is coming and then it is forcing it toward the outer edge. So, because of the vortex action, there is means this causes the drop in the pressure drop in the center where orifice is located, and the result is a reduction in the energy of water at the discharge point, resulting in controlled flow rate. So, emitter flow rate is controlled by the vortex design and orifice diameter. This is how it is happening. So, this is a means it falls under the category of the pressure compensating category, because it is less, it is coming less than 0.4. Now, specifically pressure compensating micro sprinklers, these are the another part. Here it becomes further the exponent x, it becomes further lesser than 0.1 sometime, or it is between 0 to 0.3 in this range, all that it is falling under the pressure compensating. So, pressure compensating micro sprinklers, the pressure compensate the means use the inlet pressure to modify the shape, length, diameter of flow path to control the flow rate. A diaphragm, this is a diaphragm which is placed over here, which will be coming at this place, rather it is repeated. So, this diaphragm it is made up of an elastic material which deforms to control the flow rate. As the pressure increases, the diaphragm restricts the passage of diameter. This is the beauty of this particular device. So, as the pressure compensating emitters are designed to discharge fairly constant discharge over a wide range of pressure, where emitter exponent is usually 0.1. Theoretically, it should be 0, but 0.1 to 0.3, this is the range normally it is given for pressure compensating type of micro sprinklers as well as micro pressure compensating drip emitters. A major shortcoming of the pressure compensating this emitter is the change in the elasticity of a diaphragm over time. So, the material, it is of high quality material, and this material itself is a very expensive. This is made up of silica. So, if it is means with the time its elastic property it changes. So, it does not work. So, the pressure the characteristics of pressure compensating also it changes. In addition, diaphragm will often retain some moisture when the pressure is off. The moisture may allow microbial growth within the emitter, and emitter clogging may occur. Another problem can result from the invasion of ants seeking the food, seeking a food source. All this kind of a problem may inhibit when we are using this kind of a drip emitters. The factors that affect the uniformity of water distribution from a micro sprinkler. These factors means they are affected by the hydraulic parameter of the micro sprinkler, system parameters of the network and climatic parameters of the environment. These three parameters, they influence the water distribution pattern. So, hydraulic parameters, what are the parameters related to hydraulic? It could be the pressure discharge relationship, it can be correlation with the stake height, rate of water application, and then the wetting radius. The another point is that correlation with the depth of water application, rate of discharge and uniformity of water distribution with respect to discharge and stake height. So, if someone wants to study and then design the system for a given set of condition, then one can also relate for a given particular type of sprinkler, how do such type of sprinkler they behave with the pressure discharge relationship, where the coefficient of discharge and as well as the exponent can be determined. Then one can also for a given set of condition, and then the how much is the weighted diameter, how much is the what was the application rate at a given pressure, and for a given stake height how does it behave. So, this relationship can be, so such relationship can be established, and when this particular type of sprinkler micro sprinkler system is installed in a field. So, this will help to obtain the higher uniformity of water distribution. The system parameter mainly with the pressure losses in the pipe network, the influence of climatic parameter. Now, climatic parameter, it is the mean wind speed, that also it changes the uniformity of water distribution, temperature of the place, because that influence the evaporation. So, when the water sprinkles, so droplet it gets evaporated before it falls on the ground or it falls on the plant foliage. Humidity on evaporation of the sprinkling water, this also influence. So, such parameters are considered while we are interested to get the better uniformity. So, that should be considered while designing. Now, the next point here is system layout and components. So, layout of the system, it consists of control equipped with regulating valves, more or less same way what are same equipment except the fertigation equipment, all other equipment are needed in case of drip micro sprinkler design. Only thing that their filter size may be of the image size will be differing, of course, that will also depend upon the quality of water. So, these valves means water regulating valves, that is a non-return valve, shut off valve, as well as a filter. So, the 200 to 300 microns or 40 to 60 mesh, and no injectors are needed, because in this case fertigation is except in few fertilizers or chemical when as and when needed, that can be connected, but as such the other fertilizers, because it may be harmful for the on the leaf of the plant. So, the fertigation system is not recommended to use in micro sprinkler irrigation system. The arrangement of main and sub main lines, hydrants, manifold is the same as a drip irrigation piping network. The size of the manifold feeder lines should be 50 to 60 millimeter in case the pipe size is of 75, means means in no case it should exceed more than 75 millimeter. Now, pipelines of 50 to 63 millimeter are recommended for the flow carrying water of 12 to 18 cubic meter per hour, when the water is distributed en route continuously. For that purpose, such type of layout is suggested. And then the pipes used for the systems distribution network are mainly rigid PVC pipeline. It could be PVC or the HDP that can be laid, and these can be laid above the line. This could be laid below the ground surface depending on the conditions available there. Irrigation scheduling. This system enables high degree of control both when to apply and how much irrigation water to apply. So, means the timing as well as the depth of water is to be taken into consideration. That is how the irrigation scheduling is defined. So, restriction imposed by the system are limited, thus there are more timing options in the irrigation scheduling program. The vegetables are mostly shallow rooted crop. So, selected option is generally that of fixed depletion irrigation. So, means the fixed depletion that can be applied. The application depth of about 20 to 30 millimeter is a common. Of course, such values are to be determined depending on the climatic condition, depending on the particular type of crop and its rooting depth, but this is a general value that one can use this depth of irrigation. And total water requirement, it varies from 300 to 400 millimeter in terms of depth. This is for the whole crop season, and total number of irrigation required is about 12 to 15 at intervals of at appropriate interval. So, here in micro irrigation system, or whether it is a micro sprinkler or drip irrigation system, we are mainly focusing that the water soil moisture depletion should not be more, so that and it should it should be at the field capacity, so that the plant does not have to suffer due to moisture content unless and until there is a shortage of water supply. Then the deficit water supply program can be made, where strategy can be made to supply water at deficit way without compromising the yield of the crop. Emitter wetting pattern, you can see here that this is the one of the wetting pattern where you see wetting pattern of a spinner type of micro sprinkler. So, in case of a spinner kind of a micro sprinkler, what we see, the wetting is at the near the sprinkler head. This is the this particular side you can see that this is the center at which the sprinkler stake is there, and when the spinner type of sprinkler is there, this is a typical water distribution pattern, but the more depth of water is obtained, that is based on the research carried out, it is obtained at the near the sprinkler stake. So, wetting pattern of a micro sprinkler are an important for sandy soils where root zones are shallow. This is for a specific case when the for sandy soil, and spinner emitters are of higher application uniformity than spray type of emitters. Both type of emitters will give higher uniformity when pressure is higher than 103 kilopascal. And now, this is the values. So, what you see, this is about 6 times the water here available, it is more than 6 times more than the at the outer periphery. So, this is the typical water depth pattern, and then this is the another type of wetting pattern for the spray type of micro sprinkler, where in case of spray type of micro sprinkler we see the water depth of water at the outer periphery are considerably large as compared to the near this stake. So, this is the another way that the how the water distribution it has taken place. So, by using the catch can and then the data were collected, and then it is found that the how the data are, how the moisture distribution or water what droplet distribution it takes place. So, on either side the data were it is here it is seen that it is about 3 meter on either side. So, this is the more or less you can see here about 2.5 meter is the radius of about 2.5 meter is the radius of the coverage, and then at the outer radius the depth of water is more as compared to the center. Design criteria for micro sprinkler deliver the water in low application rate and in fine drops. Such drops means these could be easily drifted by wind or air. So, we need to take when we need to operate the system when there is a less or moderate or no wind condition exist. Then if the wind is a problem, then the overlap should be reduced, means should be increased, overlap should be increased. So, in order to ensure high uniformity of water application, the spacing should be decreased or where overlap should be increased, we can say not exceeding 50% of the diameter of coverage. So, sprinkler spacing along the lateral between the lateral along the lateral as well and between the lateral, it is normally given as a 5 to 7 meter. So, this is what you see when the sprinkler, this is the sprinkler and this is the waiting circle it has been formed, and then the another sprinkler which is placed. So, here it is about 50% overlap it is given. So, this keeps on overlap. So, the water which is getting received by the land surface. So, this kind of a soil moisture distribution it takes place. So, individual sprinkler overlapped and resulting distribution of water in the soil. So, individual sprinkler overlap it looks like this, and then when the resulting distribution of water soil moisture it looks a uniform. So, this is the requirement for getting very good higher application efficiency. Hence, the common spacing is 5 meter by 5 meter, 5 meter by 6 meter. So, depends on the particular type of emitter and its waiting diameter. Furthermore, to mitigate the adverse effect of wind, relatively large number of sprinklers per unit area should be operated simultaneously. The operation shift should be arranged so that the area irrigated at the same time is compact as possible. Generally, micro sprinkler laterals are made up of low density polyethylene pipe of 32 millimeter diameter, and so as to it becomes easy to handle as well as assemble and place it to the other side. The maximum possible length of the various size of lateral on the ground level depends on the number of sprinklers and the spacing and the flow rate. Other component design is similar as we discussed in case of drip irrigation system. So, these are the reference books, and so you may please refer these papers, these books for your much more details study about this topic. And let us summarize this particular lecture. We discussed about what is a micro sprinkler, what are and then rotating as well as static type of micro sprinklers. We also discussed about different other types, that is orifice, vortex, pressure compensating micro sprinkler, weighting pattern of micro sprinkler, irrigation schedule and design consideration. So, these points we covered in this particular topic, and in the forthcoming lecture we will discuss about the bubbler irrigation system. So, thank you very much for your kind attention.